Hello and welcome to the course Climate Hazards and Disaster Mitigation. Today's learning exercise is based on formulating a flood emergency action plan. What have we learned so far? We studied important disaster management frameworks and the linkages between DRR and SDGs. We understood the key aspects and major provisions of the Disaster Management Act 2005 of India, and we also identify major gaps and challenges in implementing the Disaster Management Act. Today's our learning objective will understand the concept of an emergency action plan and relevant important terms. We'll establish key steps involved in formulating a flood emergency action plan, and we'll discuss a case study related to a specific flood emergency action plan. So to begin with, let us understand what is a flood emergency action plan. So a flood emergency action plan is a detailed written document outlining predefined steps for individuals, organizations or communities to take before, during and after a flood to minimize harm, protect assets, ensure safety and facilitate quick recovery by clarifying roles, responsibilities, communication, evacuation procedures and resource allocation for an organized response. So technically the FEAP is a well compiled document which will guide an individual or organization to take specific calls, and their roles and responsibility are defined. So for each city or each dam, if you want to prepare an FEAP, it will be different. You cannot replicate the same. Of course, the broader structure can be same, but the specific details will be different depending upon their relevance. So it links to broader risk management. It uses flood data, details actions for different emergency phases to prevent loss of life and property. So there are four major steps to it: trigger, authority, action and outcome. So trigger refers to events like extreme inflow, high reservoir level or risk of dam failure that could trigger your floods. Authority can come under the purview of dam operator, district administration and disaster management agencies. Action, whether you should have a controlled release, some warning should be given, and what should be the emergency evacuation plan. Lastly, the outcome should be reduced loss of life, property protection and coordinated flood management. Before moving ahead, we should know certain important terms in context of FEAP. So benchmark, that is a permanent or temporary monument of known elevation above the sea level, which is used as a vertical reference during construction for topographical surveys. So different levels, if you look at the dam, the FRL, that is a full reservoir level, will be 345 feet or let us say 105.15 meters. So that FRL corresponds to the elevation above the sea level. So sea level becomes your benchmark, and there can be temporary benchmarks also. Sea level is a permanent benchmark. Breach refers to an opening through a dam resulting from a partial or total failure of a dam. Dam is a barrier constructed across a watercourse for the purpose of storage, control and diversion of water. Emergency is defined as a condition which develops unexpectedly, endangers structural integrity of a dam or downstream property and human life, and it requires immediate action. Failure is categorized by catastrophic breakdown of a dam, characterized by sudden, rapid and uncontrolled release of the impounded water. Floodplain, the downstream area that would be inundated or otherwise affected by failure of dam or large flows. Most of the terms we have already encountered in this course so far, but still in context of FEAP, we need to know what are the specific definitions. Flood profile, it is an elevation view showing the relationship of water surface elevation and natural ground elevations for a discharge at a given location along the longitudinal segments of the water course. So if this is the river which is going and we have the water level here, so this will give us the depth at each point and we can have our flood profile. Flood routing, it is a process of determining progressively over time the amplitude of a flood wave as it moves past a dam or downstream at successive points along a river. So for example, in plan, if you see, this is a river and this is a dam from where the water is released. So at different cross sections, if you want to visualize how the flood amplitude is varying, you can plot the flood hydrograph and see how it is propagating. So with this, what is a hydrograph? It is a graph showing discharge stage. Stage is referred to as depth of flow with respect to mean sea level. With respect to mean sea level, then velocity. So any graph showing the variation of discharge stage or velocity with respect to time at a particular point, that is called a hydrograph. Headwater, in case of a dam, headwater refers to the water immediately upstream of a dam, and in the downstream whatever the water, that is called tailwater. Inflow design flood, the flood hydrograph. So a flood hydrograph would usually look like this. We've already seen when we are discussing the flood. This is discharge meter cube per second, and this is time t in hours. So this is your flood hydrograph. So it is used for the design of a dam and its appurtenant structures, particularly the spillway. So this is called the spillway of a dam, from where the water will spill downstream. So this phase is called the spillway. For determining the maximum temporary storage and height of dam requirements. Inundation map, a map showing areas that would be affected by flood conditions or by uncontrolled release of reservoir water due to failure of a dam. So we have gone through all the major terms that comes under FEAP. Let us understand the components of FEAP. First is activation triggers. So there are specific conditions like extreme inflow, high reservoir level, or risk of dam failure that activate the emergency action plan. Without these conditions occurring, you cannot activate the plan. Otherwise, they are normal conditions. Only if you find these triggers, then your FEAP can be activated. So roles and responsibilities, there are clear assignments of duties to all stakeholders, whether government, agencies or individuals. There are communication protocols which are established how warning should be issued. For example, there will be an operator who will transmit the message to the dam authority, then to the executive engineer, chief engineer, and then district collector, and so on. So there is a protocol being set up. In case of any unforeseen situation, there are designated routes of exit which have to be determined, how people will be evacuated. The inundation map would delineate areas that will be flooded as a result of dam failure. Asset protection, steps to secure equipment, shut down critical systems and relocate valuables. There should be phased action where specific steps for preparedness before, response during and recovery after the disaster are defined. And lastly, resource management, identifying needed supplies, equipment and recovery sites. Now let us go to detailed steps. So there are 9 steps in total. So step 1 is to determine the potential inundated area by defining PMF, that is projected probable maximum precipitation, projected maximum flood, SPF 500 or 100 years return period flood, dam break profiles downstream of the dam. So conditions to be considered may include fair weather dam failure at normal full pool levels, design flood with and without failure as appropriate, other flood flow conditions, and with and without failure to determine the worst case scenarios. Now when we talk about extreme rainfall combinations which can result into flood, we have PMP, that is called the probable maximum precipitation. So that is an extreme trigger which we can use to define the probable maximum flood. So PMP is the greatest depth of precipitation for a given duration which is meteorologically possible at a particular location and a particular time of the year. Mostly in these studies, SPF is largely used, where SPF is the design flood representing the most severe flood reasonably characteristic of a region resulting from critical meteorological and hydrological conditions, excluding extremely rare combinations. When we talk about PMF, that is probable maximum flood, so PMF will include extremely rare conditions while SPF will not include extremely rare conditions. That is why SPF is generally 40 to 60% of the PMF. So whatever is the PMF value, it is greater and SPF is lower because it will result to moderate failure risk. Now there are CWC guidelines corresponding to dam safety which have been under the DRIP project. So they have classified the dams according to two criteria. One is a hydraulic head and second is a gross storage behind dam. So the classification is into small, intermediate and large dams. So for small dams, the gross storage should be between 0.5 and 10 MCM and hydraulic head between 7.5 to 12 meter. Intermediate, gross storage between 10 to 16 MCM and hydraulic head between 12 to 30 meter. And for large dams, greater than 60 MCM and or greater than 30 MCM. So the overall size of the dam would depend on greater of either of the parameters. So if any one of the parameter is exceeding the other, then that particular classification would be taken. For example, if the gross storage is in this range but hydraulic head is in this range, then we will consider it as a large dam. Now based on that, inflow design flood for the dam safety is as follows. For small flood we consider 100-year flood, intermediate SPF and large as PMF, that is probable maximum flood. First we identify area. So we are taking a part of this from the study by Jipkate et al. So you can see that Ukai Dam across Tapi River. So Tapi River is in the western part of the India. So the terminal reservoir in the Tapi River basin is the Ukai Reservoir. So you can see this is your Ukai Reservoir at this particular point, and downstream of Ukai Reservoir you have the Surat city, where the river passes through the city and then merges into the Arabian Sea. So in Surat city, this study has classified important infrastructure and done an extensive flood modeling to identify the inundation areas for different conditions. So you can see this is a detailed map, ward wise map of the Surat city which is being created. Now some salient features of the Ukai Reservoir, again taken from the same study. What is the maximum flood which is observed is 42,000 cumecs. PMF is 59,920 cumecs, while SPF is 49,490 cumecs. What is the maximum regulated outflow from the reservoir? It is 24,100 cumecs. The gross storage capacity at FRL, that is full reservoir level, is 7,414 million meter cube. Live storage is 6,729 million meter cube, and the highest flood level was observed as 106.99. So these salient features will help us determine, analyze the conditions of the dam much better. Coming to the hydrograph, you can see this is the hourly hydrograph for the 2006 floods which was observed. So the flood peak was, that is the inflow hydrograph, that was 34,118 meter cube per second. The outflow peak will be slightly less, that is what is called flood routing. The inflow peak is moderated by increasing the time base and providing some time lag. So this time lag is very important in case of flood routing. So the flood is delayed and it is attenuated also, that is the peak effect is reduced. This figure shows the reservoir capacity curve, that at different elevation what is the storage capacity of the reservoir. So at the end the study quantifies the inundation area. So here you can see this is the Surat city, and different legends are given starting from blue till red. So the red indicates that more than 6 meter depth was inundated at this particular area. So there are two conditions being simulated. One is failure that happens at the full reservoir level, that is FRL of 105.15 meter, and failure happening at 1 meter overtopping. So if the dam fails by overtopping, then what can be the scenario? So in this inundation map you can clearly see that the areas marked in red are the areas inundated. So these red zones are very clearly delineated. But when we see this condition is more critical, where you can see the red zones are more and more predominant in this particular map, and this will help us clearly depict which areas are flooded. While preparing the inundation maps based on the flooded areas which are determined in step 1, there are certain category of maps which are to be prepared. First is the index map, which will list all towns and villages, important public buildings, railway stations, railway lines, post and telegraph offices, which may come under the flood line, and the prohibitive, restrictive and caution zones to be marked on the index map. List of villages along with their population should also be enclosed in the report, and the index map should be prepared to a scale of 1 in 50,000. Coming to the detailed maps, the hypothetical dam break flood line, the 25 and 50-year return period outflow, and the maximum spillway discharge of the flood line, various populated sectors, streets, roads, public buildings, and important installations like power plants, thermal or nuclear power plants, government buildings, etc. should be marked properly on the maps. The maximum inundation map should be prepared, which shows the area that would be flooded in the event of failure of a dam, because that is the worst criteria that could happen. See, in regular functioning, the dam would release water which can be result in flood, but the worst criteria is dam fails and the entire water comes instantaneously. That is the worst case which we need to prepare for at a pre-specified breach elevation, and different depths can be shown by different colors as we already saw in the previous maps. The maps also shows the area affected by a maximum spillway release of discharge with the reservoir at a specified RL by the pink area. Last is the leading edge time maps. Leading edge time maps show the travel time of flood wave in the event of failure of a dam. So for example, if a dam fails and there is a city here, how much time it would take from here to travel at this location, let us say 1 hour or 2 hours. So that time we get as a buffer to evacuate people from this particular location. So the travel time should also be included. Step 3, determine and identify those situations or triggering events that would initiate an emergency action and specify actions to be taken by whom. So which are the triggering events? Extreme storm, there can be landslide, earthquake, overtopping. Overtopping is when the water level exceeds the dam top due to displacement of the moments, the dam may fail, that is called overtopping. Then structural damage, any other structural damage to the dam. Piping is usually observed in case of an earthen dam, where the earthen material fails due to piping action. So earthen dam may fail. Some equipment malfunction like gates are not opening, so that adds extra thrust and that could result in failure. Foundation failure or sabotage. This sabotage is usually some kind of activity where bombs might be placed or some kind of purposefully done activity, that is sabotage. So different emergency levels. So first is the internal alert, that is blue, that is watch condition notifications. So in blue, what will happen? The watch condition will indicate a blue emergency level. They will monitor the situation closely and take corrective steps. So what happens in case of a blue emergency level? That you will analyze what is the meteorological conditions, whether the adverse meteorological conditions are there or not. For example, IMD has forecasted very extreme rainfall, so that becomes an adverse condition, so that should be noted. If during the dam safety inspection some minor foundation problems are noted, then that also becomes your blue alert. Next comes the orange alert. In this, situations with high probability of dam failure are there, where you detect severe anomalies in the dam structural elements or operational elements. There are existence of severe problems or occurrence of extremely large floods. So in this case, you analyze a certain condition and some amount of time will be available to analyze decision and before taking a final call. So here orange alert is flagged. We have to take corrective emergency measures to solve the problem and warn the population downstream to prepare for evacuation. Lastly is a red alert. In red alert, the dam failure is imminent. The dam will surely fail. You cannot prevent it because the flood waters might overtop the dam crest, appearance of large flows through the channel if there is piping, and the dam failure has begin, that is in progress. So there will be no time available for analysis, decision, mitigation and other things. So red alert is flagged. Issue the most severe evacuation warning, focus on evacuating the people at higher risk, and the action should be immediate evacuation. So red alert is one of the critical alert which cannot be reversible. Next is identify all jurisdiction, agencies and individuals involved in the EAP. We'll discuss the development of EAP with these parties. The interaction should include discussion on need for the emergency operations, how the evacuation would happen and what should be the post-flood actions. Fifth step, identify primary auxiliary communication systems, both internal, that is persons at the dam, and external, that is between dam person and outside entities. So internal, like all people working on the dam, they can access this information, and after that this information goes to the outside entity. Sixth is list and prioritize all persons and entities involved in the notification process and draft notification flowchart. A minimum of 2 notification flowcharts are needed, one for each emergency condition, showing people to whom warnings are to be issued during the emergency and order in which it has to be contacted. So what are the pertinent questions? So blue is the watch condition while orange or red is the failure condition. So accordingly the trigger should be given. So first condition is a watch and second is a failure condition. So these are the true emergency conditions. So flowchart should clearly say who is responsible for notifying each representative and public official, who is to be notified, the order in which people and offices are to be notified, individual names, position titles, whether that person is engineer, chief engineer, executive engineer, so on, their office location, home location. Sometimes people are not reachable, then they can be contacted at their home, mobile numbers, 24-hour telephone numbers, alternative contacts and other means of communication. So here's a particular step. For the watch condition, what is a flowchart? The observer will see the event. It will contact the site office of the dam owner. So you can see the operator, this is the position and this is the name, then they have contact number and then office number, mobile number and so on. So all details are there. Then the third trigger will be to the Office of Planning and Design. Then there will be for communications to the executive engineer, superintending engineer, then it will be further triggered to chief engineer, then state dam safety office and so on, and lastly the available resources whatever are required, they will be contacted. So this represents the order of notification in which the notification has to be provided. Unless you have a clear-cut order, there will be always chaos, that whom to contact first to contact either executive engineer or chief engineer or somebody else. So there has to be a proper hierarchy and sequence which has to be maintained and this protocol should be formulated beforehand. For the failure condition, what is a flow chart? Again, the observer will tell to the dam site operator, and in case of a failure there are a lot of changes. Immediately the message goes to the district collector, executive engineer, then CWC divisional office, then again it goes to the dam safety office, owners of downstream dams if there are more dams in the downstream, CWC regional headquarters, and then collector will pass on to critical infrastructure, that is power plants, refineries, road, railways and so on. And the resources also required. Let us say you cannot mitigate, but sometimes you can do some interventions. Step 7, develop a draft EAP. A suggested format is already prescribed by the Central Water Commission. Then step 8, the coordination meeting should be held with all parties and also non-governmental experts should be involved. Last step, make revisions, obtain necessary approvals, concurrencies on EAP, disseminate EAP to those who are responsible under the plans. So all those who are responsible person, everyone should be given a copy of the EAP and sanitize what is your role in this. At least once a year the dam owner should update the EAP. Let us say why it is required updation. For example, they designed for certain flood level and that year the flood level breached the previous level, then you require an updation, or you should review whether it happened or not. And at least once in 5 years they should carry out a tabletop drill to test the efficacy of EAP. Whether some components are not well, then it should be there. And yearly updation is required because some people get transferred, so the contact details should be updated. That is very important. Coming to the SOPs, so standard operating procedures are already defined at dams, what to do in what case, which gates to open, how to proceed, so that is already given. So these well defined SOPs are very essential to coordinate actions among different stakeholders. Now there can be variations in SOPs when we talk about urban floods, because Based on the geographical and physical locations of the conditions, the city-based procedures can differ. For example, in case of coastal cities, flooding is influenced by high tides. So short-term measures could be, clean natural and man-made drains, and long-term or medium-term promote more rainwater harvesting at household levels. Inland cities, water stagnation is major issue because there is no nearby water body where the water can escape. So their drainage should be improved by removal of silt and waste, the solid waste which we dump into the drains. We should restrict the development in natural catchment areas, and afforestation and pond revival should be thought of. Hill towns, because there is very fast runoff, erosion and landslides are also an issue. Mud flows are obviously there, so drains should be cleared. Floodplain should be declared as a conservation zones, and there should be afforestation to control floods and landslides. Cities along the river, they can be affected by changing river course or sudden discharge. So Kosi was a very well example. So dredging and desilting should be done. Promote raised or stilted buildings. So buildings should be, the level should be raised, and construction in vulnerable zones should be restricted. Conserve and interconnect natural and artificial water bodies. And lastly, cities near dams and reservoir require a combination of all above measures with strong coordination with the reservoir management authorities. We discuss a case study here. Surat city, as discussed earlier also, setting. This is the Ukai Dam. Downstream there is a Kakrapar Weir, and around 120 kilometers from the Ukai Dam there is Surat city, and from there around 20 kilometers is the Arabian Sea. So this is where the EAP has to be developed. The population of Surat city is close to 50 lakhs. The area is 462 square kilometers. Now looking at the flood history, 1968 there was a very heavy flood. So this is an archival photo, you can see very heavy flood in the Surat city. So this is one of the very worst flood where the release, Ukai Dam was not in position. So Kakrapar Weir, there was around 15.6 lakh cusecs water there. So post Ukai, the floods which are very prominent, so there is a typo error, this will be 2006. So 94, 98 and 2006. 2006 flood we already saw earlier what was the situation. Now it was triggered by sudden large releases from the Ukai Dam. So this is one of the triggering. There was large parts of the Surat city and nearby village which was submerged. Severe impact on urban poor and tribal communities, and it exposed gaps in reservoir operation, warning system and flood preparedness. So we should enhance reservoir operations and emergency preparedness. So 2006 flood which severely affected the city was a significant factor in triggering those floods, and it also triggered that we should come up with an FEAP. So the implementation involved by setting up a hydrological model, utilizing rainfall forecast data and generating inflow forecast. So the project impact includes better dam management to prevent flooding, use of hydrological model for inflow simulation, and provide what is the releases so that the flood situation can be monitored. What should be the preparedness before the onset of monsoon? The District Disaster Management Authority and the Surat Municipal Corporation should undertake certain preparedness measures. It should review the Ukai Dam rule curves, flood cushion availability, inspect the embankments, sluice gates and drainage channels, update flood inundation maps, identify flood prone wards, evacuation routes and shelters, training of municipal staff, fire services and disaster response forces, and public awareness campaigns in the low-lying areas of the Tapi River. Continuous monitoring is required during the monsoon. Surat operates on continuous monitoring driven by basin scale information. So IMD would provide rainfall forecast for the Tapi basin. CWC will monitor rain gauges and discharge levels. Ukai Dam authorities will track what is the catchment rainfall, reservoir inflow and storage levels. All this data are shared in real time with the district collector, municipal corporation and state emergency response centers. Here's a line diagram. You can see it is very important because it gives you a perspective of the features. So it is a very systematic presentation of the river view. So it shows the dams. So you can see all the dams are there, all the gauging sites are shown, estimated flood travel time. So what we are discussing earlier, so from this point to this point, that is a 17 hours of flood travel time. Then from here to Surat city, what is the flood travel time? So from Ukai Dam to Surat city, the flood travel time is around 6 hours. So from Hathnu Dam till here 24 hours. So all this travel time information. So this will support our early warning and evacuation, also enables a very coordinated interagency response. So this this line diagram is all prepared for all such major systems, which eases our work and reduces uncertainty in the emergency action plan. Information dissemination is very important. The SMC disseminates daily hydrometeorological data including rainfall, river stage and reservoir levels on the website. So on the website you can see what is the current level of the reservoir, what is the storage or level at the Viercom Causeway, again dam levels, what is the rainfall, everything. So you can see zone wise rainfall is released. So SMC gives continuous monitoring during the flood season. Alert and warning which is raised, so the dam release thresholds will trigger the alerts. So there is always advisory from that regarding low discharge, moderate and high discharge. Once the high discharge is released, public warnings are issued, activation of flood control room and preemptive evacuation happens. So the communication channels include SMS and mobile alerts, loudspeaker announcements are also there, television and radio, and coordinating with the ward level officers. So what is the dam release threshold? So there are 4 stages starting from the blue one, that is advisory or caution stage, where dam will release around 1.5 to 3 lakh cusecs water. So cusecs is feet cube per second, because in the dam manual it is mentioned that way, so we are using the same terminologies. And the river level at the Hope or Nehru bridge should be 7 to 8 meter. Warning level, the range is given, but it will be somewhere 8.5 meter and danger level will be 9.5 meter. So warning stage, you should be ready for evacuation when this much amount of water is released from the dam, and action should be your flood warning to the vulnerable wards, relief shelters should be prepared and ward level officers should be mobilized. Danger or evacuation stage, purpose is life safety. Dam release is greater than 5 lakh cusecs, river stage greater than 9 meter. There should be mandatory evacuation from flood prone zones, and fire brigade, SDRF and NDRF should be deployed. Last is the extreme flood stage, where disaster response and rescue should be carried out when dam release is more than 7 lakh cusecs water, river level is more than 10 meter at the Nehru bridge. Full emergency operations, rescue operations using boats, helicopters and medical emergency services should be there. So this was seen in the events of 1968 and 2006. Evacuation and emergency response, so the phase protocol should be followed where the riverbank settlements, low-lying wards and informal settlements like a slum area should be evacuated. Fire brigade boat should be deployed, disaster, that is SDRF, NDRF team should be there, and police for traffic and crowd management. Activation of temporary relief shelters, medical camp and food and water supply should be provided. Special focus should be given to elderly, children, hospital patients and migrant workers. There is a need to set up a command, control and coordination center, that is a centralized flood control room in Surat, where 24/7 operations are monitored under the supervision of district collector. Dam authorities, municipal department, health and services, police and fire services are coordinated, and real-time updates on river levels, because water levels will go up, go down, so that should be monitored continuously. Dam release, inundation status and evacuation progress are continuously monitored in that control room. What is a post-flood recovery and review? What is the damage assessment should be made? Restoration of water and power, water supply, power and transport, and health surveillance to prevent disease outbreaks. Then they should review the reservoir operation, hydrological model setup, how effective is the rainfall forecasting, and how did the early warning system perform. Coming to the last part, where we show an initiative so this is a Mumbai flood app. So it is an experimental app developed by the Center for Climate Studies at IIT Bombay. So this app aims to support Mumbai's monsoon flood preparedness through real-time forecasting and monitoring. So the entire idea is citizen-centric involvement supplemented by technological innovations. So in the key features of this app are the hyperlocal rainfall forecasting, so AI/ML based enhanced hourly observations and 3-day rainfall forecast, live water level monitoring at different sites, so you can see where the water level monitoring are kept, and real so this is a typo error, so it is real flood information. So near real time flooding status of local train for transport communication etc. is also provided in this particular app. Key takeaway from this lecture that EAP is a formal plan of procedures designed to minimize consequences of life and property in the event of emergency at a dam. Determining the potential inundated area by defining flood profiles downstream is the foremost task in an EAP. Determining and identifying situations or triggering events would initiate an emergency action and specify actions to be taken and by whom. Lastly, list and prioritize all persons and entities involved in the notification process and clearly define their roles and responsibilities. Here's an activity suggestion for you. Prepare an outline. So all the components of the emergency action plan for a dam or city in your vicinity as per CWC guidelines. So just prepare an outline. What are the components involved? So here are some very good additional learning resources from you, guidelines for developing EAP and other documents. Thank you for your attention. In the next lecture, we will discuss some advanced topics, that is role of big data in climate hazards and disaster modeling. Thank you.